My name is Paul Martell, and on behalf of Actifio, I'd like to welcome you to today's Masterclass webinar series. Before we get started, just a couple of things I want to point out. Please feel free to ask us questions today using the question tool on your screen. I'll be standing by answering questions as they come in, although we will save some of those questions in order to talk to them on air. After the webinar, there is a survey. Please take the time to tell us what you think and what you'd like to see in later sessions. Your feedback is very important to us. Again, please take the time to complete that survey. Our next webinar is administering and reporting using Enterprise Report Manager, which is on February 14th, 2 weeks from today. And we have an upcoming live remote Sky administration class, which is being held February 12th to the 16th. Today's presenter is David Fowler. He is the manager of Global Enablement. Dave, you want to take it away?
Thank you, Paul, and thank you everybody for joining us this morning for our webinar on job analysis leveraging Actifio logs. Now, time and time again, I've heard feedback from our customer base. Oftentimes you could run into an issue, you may have a question, so you reach out to our support team. Our support team will go in and they have access to logs that you would generally need root access to be able to see. This is no longer the case. Today we're going to discuss how to get that exact same formerly root level only access log set out of your CDS or Sky appliance and onto your desktop so that you can use tools like PowerShell or Vim to search through it and start to learn how our product works a little better, work towards some of your own problem resolution. And we do have a growing user base who's using our API or just direct command line interface to run functionality like an Ansible or ServiceNow, some sort of automation for trouble resolution. So the first step is we need to get ownership of these logs. That is to say, we need to get them on our desktop and out of the CDS. And this removes the requirement for root level access to view what's in these logs. So we're going to start with the domain manager, and that's the small bullseye-shaped icon down in the toolbar on the bottom. From there, we're going to go over to the left-hand pane, and in the bottom of the configuration dropdown, you'll see a selection for logs. And now there are a couple ways that we can get the logs. As you can see up at the top of the screen, email, jobs, events, and download. The two important ones here today are email and download. Now the logs, once combined and zipped into a package, can get fairly big. That's to say they can be in excess of 10 to 20 megabytes, which sometimes exceeds the quota of the inbound email server, and they'll refuse the mail because the attachment is too big. For today's examples, we're going to use download. So once we click download, we're going to go from the 6 o'clock position, we're going to go counterclockwise around here. And really, you could do this in any order you like, as long as you obviously click the download logs button last. But we're going to start at the bottom. There's a select host dropdown. We're going to select the host that we want the logging on. Then we have a huge pick list here of all the different logs. And again, these are all the logs that were formerly hidden behind root level access that you had to engage support to get access to. So for today's example, we're going to download all of them. And during the presentation, I'll help you get a more narrowed list. So when you know what you want to look at, you'll know exactly what logs you need. So you're not downloading more than what you need. Now, the third step is going to be to pick a date range. You want to pick as small of a date range as possible while still capturing the full job for the host that you want to look at. Lastly, once you've got all your selections made, click download logs. Now the download logs button will actually take all those logs, make a copy of them, zip them into an archive, date that archive, and then it will download them to whatever is the default path for your default browser. Generally, this is either going to be the downloads folder under your user profile or sometimes right on your desktop. And again, the larger the date range is, the more logging you will get. However, the longer this is going to take to gather these logs, compress them, and then transmit them to you. We do treat the log retrieval operation as a very low priority operation, meaning if the CDS or the Sky appliance needs to decide between making a snapshot and sending you these logs, it's going to go ahead and do the snapshot, and then when it has a cycle free, those logs will come to you. So here we'll go through all of the logs and I'll tell you what's in each one. Now, all of these are not going to be pertinent on a day-to-day basis, but I do want to let you know what's there and what's in them, just so you're aware. So the very first one is the ADHD log. Now, this is the dedupe log. This captures everything for dedupe, direct to dedupe, and remote dedupe. This also covers any sort of remote connections to other clusters. So if you have a remote DR site, either on the other side of the world or just on the other side of the data center, the communication between these clusters will be logged in the ADHD logs. If you have a dedupe issue, the ADHD log is the log to use. And we have an appliance folder. This has a couple different logs in it. Now, this is generally the CDS hardware or the VM host for Sky, the VM level log. This will talk about things like the actual condition of the host, the actual VM that is hosting the Sky. If that's suffering an issue, that will be logged in here. If you have a failover or failback, all that gets logged in here as well. And a lot of your hardware type signaling, your interfaces going up and down, all of those things are captured in the appliance folder. The connector is the one I believe most users are going to be familiar with. This is where the UDS agent log lives. Would imagine just about everybody who's got some time with our Actifio unit does know what the UDS agent logs are. And we're actually going to dive into those a little bit deeper than our documentation provided with the connector does. Next is the database logs. Now, this is not the actual platform database. This is not the Postgres database that sits in the CDS. These are the Postgres logs. Generally not very useful to the end user. However, if you are Postgres savvy and you'd like to take a look through them, feel free. DDS is dedupe transaction logging. Now, what this really is, these are really performance metrics. This is how quickly we're moving across the disk, what our throughput of data is when we're trying to deduplicate. There is some what I will call user readable log messages in here, mainly for our dedupe engineers. But again, we're going to put all these logs right on your desktop, so feel free to take a look. Flasher, this is the log that coordinates between a couple of our services, and this covers the creation of vDisks. vDisks and staging disks, for the context of this presentation, are really the same thing. So you will see them used interchangeably. A lot of places I'll note both names just to help you make that connection. The install folder contains the install logs. If you're trying to self-install a Sky and it's trying to give you a little bit of trouble, you can pull these install logs down and you'll get a more verbose, maybe more useful bit of logging to help you troubleshoot your installation. Networking is exactly what it sounds like. That's going to be routing, default routes, interface events. If you have any sort of specialized routing, all of that's going to be in the network folder. This is actually one of the folders that we capture prior to upgrading your appliance. So if there are any issues and the routes aren't the same after the upgrade, we can then go into that network folder and start putting things back the way they were. Next is OMD. Now, OMD is the Object Manager Daemon. This works in conjunction with Flasher for the creation and deletion of vDisks. This also is what tracks use of vDisks. So when you go into your UI and you take a look at all your vDisks, how you've got them allocated across your different appliances, the OMD service, or Object Manager Daemon, is the actual service that's displaying all that information for you. The pserv, this is our main communications service. This speaks with Tomcat. It talks to our Actifio database that I referenced a moment ago. And it's also going to talk directly to VMware via your vSphere or ESX API. It interprets commands from our CLI. It tracks system health. It runs the scheduler. And it also, without propelling GC, does kind of monitor it. GC is largely going to be logged in the ADHD log, which we saw first. Then we've got the StreamSnapD. This is disk to remote disk replication. Now, this is anytime we're going to send data across the wire without deduping it in the traditional remote dedupe fashion. System log, for you Unix fans or Linux fans, this will be a little bit more familiar to you. We have the command log, which is the CLI history, the same output that you would get if you ran history on a Unix machine. We've got the fuse disk error log. So if we were trying to create a staging disk out of your set of M disks, and it does result in an error, those errors with more specific output like UUIDs, paths, will be called out in the fuse disk error log. Messages, this is again, for Unix folks, this is just like var log messages. For people maybe less savvy with Unix, these are a lot of system level messages. When a drive gets mounted, you'll see it logged here. You'll see be assigned a drive, letter, partition, what have you. The SSD config log only tracks events that occur with the SSD. So if you're not using SSDs, you just kind of expect a lot of noise in here. It will say, hey, we still don't have SSDs, kind of in perpetuity until SSDs are installed. And if you don't ever plan to install them, there really isn't much need to dig into this log. Next will be Tomcat. That's exactly the Tomcat you're thinking of. It's a web service. You'll also see this under Catalina.log. This is communications with the Actifio desktop and our resource center. For those of you who may not be familiar, if you go to the IP address of your CDS in a web browser, it will bring you to a resource center, which has connectors, documentation, self-service networking panel, all kinds of great little tools to help you get going with the Actifio appliance. Then we've got the OpenVPN logs. Now this is strictly for Secure Connect. That is the connection mechanism by which our support or services team may use to connect directly to your appliance remotely. Almost done. So next we've got UDPMQD. We really don't spend much time looking at this one. This is the multiplexing logging for the UDP engine to snap storage. So our UDP engine is the engine that actually moves all of the data around within the CDS, and we can access your data via multiple paths. We are leveraging the exact sort of multipathing that you are going to set up between your physical host or your virtual cluster and your storage. So if you've got 4 or 5 paths that we can access your storage with, the UDP MQD log will describe how we're utilizing those different paths to get the UDP engine into play in multiple channels. UDPPM, this has got the shortest definition, but probably the largest use case. This is the scheduling and operation of jobs. This is snapshots, dedupe, remote dedupe, the scheduler, everything that pserv, that's the platform service log, interprets from either the UI or the CLI, is then interpreted into a command that our UDP engine can understand, and the UDP engine is what actually takes action on the things that you clicked in the UI or the things that you typed in the CLI. And then we have a CDS side version of the connector log. Now you've got your UDS agent log that sits on your host. We've got a little bit more verbose log. It's not so important if you understand how to read the UDP log, and we're going to spend a lot of time in that today. I want to make sure that you have a very thorough understanding of how to get through there. And it's not necessarily what I would call human readable, but I'm going to show you some tricks on how to target some smart searches to really bring you right to the portion of the log that you need to see to understand whatever your question is. Okay, so now how are we going to use all these logs? We're going to use them in part to troubleshoot some jobs. Like I said, we could also use them to kind of push forward animation efforts or automation efforts. But for the purposes of this webinar, what we're going to do is we're actually going to follow a single image from the host through Snap, through dedupe, through remote. And I've created a couple of scenarios where things don't go right. And with that, we will exercise these troubleshooting steps. So the first thing that happens, you get notified that you have a problem. You either see a failed job in the status monitor, you are looking at the failed jobs report in the report manager, or even a better report to look at for that is going to be the SLA violations report, because any job that didn't run on time will also be reported in addition to any failed jobs. Now, if you want to know a little bit more about how to set up your report manager just right so you can capture all this information in a useful way, Paul Martel will be presenting these steps in his webinar on the report manager. So next we have problem identification. We've received an alert. What does the alert say? Did it give us an error code? Now, our knowledge base has come quite a ways in the last 3 to 4 quarters. You may not be able to enter an error code and not get a result. I've tested a bunch of them, and about every error code that I've tried, you'll either get a knowledge base article on what it means, how to fix it, or you will get a link to a knowledge base article that has a document in it attached as a PDF, and the issue resolution is described in that PDF. And part of what the error code is going to tell us is what exactly broke. Did the job break? Did the snapshot fail? Did it not even start because we couldn't talk to the remote host? So we'll take what broke, and with that, we'll decide which log we need to look in. And once we know which log we need to look in, we can take a look at some of these events. And some of these problems, when you can see them spelled out clearly for you instead of just a one-line error message, you may find that you can resolve a lot of your own issues. If not, then you've actually got a bunch of great information to use to open a ticket with our support team so they can really drive right to the core of what's causing your issue. Now, this is all of our services, which all have corresponding logs, which I covered just a moment ago. I'm going to cover this a little bit quickly. I don't want to get mired in kind of the confusion of this, but at the center, we've got UDPPM. Now that's UDP, again, that's the Universal Data Pipeline. That is the engine that actually moves all the data. So you see at the top left, you've got the UI. So you go in and you say, we'll run an on-demand job. You click, pserv sees the click, understands that you want an on-demand job, and then talks to UDP and says, we've got a request for a snapshot. Do we have slots available? Can we find the disks? And it starts the process of the snap. Well, at that point, UDP will either say, thank you, pserv, we need to speak to VMware to start this snapshot, or if it's a connector or agent-enabled host, it will actually reach out directly to the UDS agent and open up the data pathway there. At the same time that it's talking to pserv, it's talking to UDS agent, it's getting in touch with the host, it's also talking to OMD, and again, that's the Object Manager Daemon. And it's saying, I have a request for a snapshot. I've talked to the host. We can talk. I've verified I've got good communication. I need you to look for a staging disk. Now, what OMD will do is if this application or host has been ingested in the past, it will know that it's incremental. It will pull the old staging disk back and it will attach it. If this is a first ingest, it will carve out a new one, roughly 20% bigger, 39% bigger for SQL and Oracle to accommodate for log growth. And it will then attach it to the host. Now, if we need to access either physical or data store storage, OMD then talks to Flasher, depending on what the storage architecture is. Flasher is kind of a bridge to help us talk to different types of storage, which is why we are self-proclaimed storage agnostic. Flasher and OMD between them can talk to all of these different appliances through so many different venues and different layers that we really work well with just about any disk setup. Now, if we come back up to the middle, so we've got the request for the snap from pserv, UDP has talked to the UDS agent, we've talked to OMD, we've got our staging disk, we're going to then talk to ADHD. Now, this is part of the scheduler. We've got a request for a snap, so now we've got this image and we want to look at the scheduler. We want to see how that app's policy fits into the scheduler. Do we have a request for a snap and a dedupe? If we do have a request for the dedupe, is the snap done? If the snap is done, can we start the dedupe? Now we'll get a little bit more into actually going through the logs themselves. All right, so once the logs are on your desktop, you're going to need some sort of utility to look at these logs. Here are a few I recommend, and I recommend them because they are free to use. If you have a favorite one, by all means, use your favorite one. If you're on Linux, I would imagine you probably have a favorite already. If not, you can check out Vim, which comes with most distros, Emacs, which is my personal favorite, or Nano. Windows, WordPad works, doesn't do a great job of actually breaking out the logs into lines. A Notepad++ is a free enhanced version of Notepad, which does a fantastic job with logs. And if you wanted to use some of the Linux shell pattern matching, like grep awk sort on a Windows machine, you could use PowerShell free or PowerShell's paid version and bring in that additional pattern matching functionality. Okay, so the image that we're going to follow today is going to be an image that I started via an on-demand job. And it also is going to go through dedupe and then through remote dedupe. So we've asked for a job. pserv sees the call from the scheduler or the UI, because in this case, I did in fact click on demand, and it starts to kick off the mechanisms that I described in that 9-square slide, where we're talking to the UDS agent, we're talking to OMD, we're talking to UDP. We've got all 5 of these services now all working in concert to manage our physical disk, to talk to our host, to start to present that physical disk to the host, open network paths, and then start ingesting that data. So if you want to see how this works, the best thing to search for at this point in the job is really going to be the job number. So as you can see here, by searching for the job number, now you will notice one weird thing about the logs. I did cut the timestamps out. and that was for no reason other than screen real estate. So you will have a full timestamp preceding each one of these log lines. So as we can see here in this example, we've searched for the job line. And as I go through this presentation, I'm going to mention some words for you that you could search in these particular logs to bring you to the important part. When we get to that slide, those words will be bolded. So you'll see what kind of search results you would have gotten had you used some of these keywords that I suggest. So here we can see everything is going well. We've found our iSCSI initiator. We've opened the path, and we're able to then talk back to OMD. And at this point, we're about 9% into the job. And we can say, OMD, we found the agent. We're able to talk to it. We've opened a good data path. Please give me a disk so I can attach it to this host and start writing. Now, if for some reason this path was offline, either physical media was unplugged, your multipath settings had it set into a perpetual queued mode, or perhaps your iSCSI network is QoS'd and the QoS has shut down the path to allow better throughput on other links. Searching for the job number is still going to bring you to the critical piece of information here. Now you'll notice we go from an info log level to a warn log level, and it will say right in the logs, we know what path you've asked us to use, but we either cannot find it, which is generally going to be a physical media disconnect, or somebody has reconfigured the iSCSI in the host, or that path is either offline or into a perpetual queued mode. Now, I've mentioned this perpetual queued mode 2 times. In some multipathing software, you can specify the behavior that a path should take when it runs into an issue. So the 2 that I really want to focus on is queue if no path. If you have a setting for queue if no path, what will happen is if you do have that QoSing or there is a media disconnect, the IO from the host will just sit waiting to go in there, and nobody was going to send an alert. And the reason nobody's going to send an alert is because everybody is adhering to the configuration they've been given. It was told to queue if there was no path. So it didn't fail to the next path and it didn't issue an alert. It's queued just like you've asked it to. The suggested setting here in a true multipath setup where you really do have multiple paths to your disk set is fail if no path. If we can't connect, we will fail that path and then we'll try to access the next available path to that host or storage. And we will go through that cycle 5 times before we, at that point, say, we just can't make a good connection. We're going to cancel the job and report it to you as failed. Okay, so we're going to go back to the beginning part of my example where we do make a good connection. So that was from the UDP log, and the UDS agent has a corresponding log entry. So pserv said to UDP, I want a snapshot. UDP said, okay, let me talk to the UDS agent. UDS agent, are you there? Is your host available? And you can see here I have in highlighted letters, hello connector. That is the log line to look for to ensure that the CDS or Sky instance has made good contact with your host. If you do not see hello connector, it means we couldn't get a signal from the source appliance into the host. And I've also highlighted at the bottom here, it gives you the version of the connector it's talking to. So if you're running version 719, and unless you have a very specific special use case, your connector should also be at 719. And this initial handshake actually does have some other really nice information in it. We can see a little bit further down that this is a log smart backup, that we do have AES 256 capable encryption that we could flip on by just putting a tick in a box. So when you find your hello connector, look a couple lines above, a couple lines below. There's some great context there, again, which would be great for tool building or any sort of automation effort that you're trying to get into. Now we'll focus a little bit more back on the UDPPM log. Now some search terms here for the initial part of the job is going to be the job number. We're going to look for the term UDS agent, and we're also going to look for ESX. So you can see here, this is from UDS agent. We just saw the hello connector. As you can see here, I have highlighted received UDS agent response. That means we said hello connector, the connector said, hello, I'm here. And then we can see some additional logging around here. There's not a lot of context here, but you can kind of dig into a little bit to kind of understand what's going on. We show the compressed size of the app. This means that we've seen it before. If the compressed size is a 1-to-1 match with the actual size, it means we've never seen this data before and we're not really sure how small we can make it. So as you can see here, we've got our comp desired size and then our comp size. So we know that we've seen this before. We've seen it at the 510, et cetera figure, and we know that we can squish this down to the 425, et cetera figure. So now that we can verify that the Actifio appliance is connected to the host, we can also check to make sure that we're using the right iSCSI path. And we can also verify this without the UDS agent. Instead of talking to the UDS agent, what we would do for a non-connector enabled host is we would reach out directly to the ESX or vSphere node, cluster, or host that it lives on. Now, in that case, again, we're going to search for the job number you can see here. And this is the important part. Message, expected one, got one entries from host agent data with ESX host name, and then we have an IP. Now, if we expected one and got 0, that means we tried to reach out to an ESX host that we had talked to before. We were able to log some details around it and run a good discovery on it, but for some reason we can't talk to it now. So if you are having connectivity issues, looking at this expected 1 got X, and if you're in a clustered environment, it could be expected 10 got 9. And then it will enumerate everything that it was able to talk to, and by process of elimination, you would say, okay, well, it sees these 9. The only one that's left is clearly the one that we can't talk to. So now that we've made our connection, either via the UDS agent or by talking over the ESX or vSphere API, we've confirmed good host connectivity. Now we want to make a staging disk. So here we're going to search for the job number, and we're also going to take a look for the word hint. And this again goes back to just making sure that we are in the incremental forever model. If we are, as you can see here, the second to last line, it says backup hint object, and then it's got that hex value after it. That is a hex value that has been assigned to the previous image. That lets us know, hey, we have a copy of this image on board. We don't need to ingest the entire app from ESX. We'll just grab the change blocks. Now, for the exact same operation, I did the same thing, but I had actually removed all of the images and I forced a full, and then we get this log message here. Backup hint object, not found, performance warning, full ingest. Now, if you're onboarding a new app, you fully expect this. We need to see it once before we can start deduplicating. However, if you have a job and you feel like maybe it's running a little bit long, it's just taking much more time than you feel like it should, you can go into the UDP log and you can search for the word performance. If you find that performance warning next to the corresponding job number that has you curious, then yes, you have encountered a full backup, and that would explain why your backup is running long. However, if you see the backup hint object, then it is a true incremental. You may have just had a large amount of change data, and it's just taking a little extra long. However, this can also point out things like faulty points in infrastructure, improperly assigned QoS, or even a physical interface that's not behaving well. Okay, so now we are actually going to call the staging disk. Now, I said before I took out all these timestamps. We've been talking for a few minutes now. In machine time, if this was happening live on a CDS or Sky, maybe 2 or 3 seconds have elapsed. This all happens very, very quickly. It does take me a bit longer to explain it because while I'm explaining to you one thing at a time, the CDS or Sky appliance is doing 5 things at a time. So at this point, we've connected to everything. We've verified everybody's good. We talked to either our agent or our ESX host. We are ready to attach a disk and start capturing that data. So again, the UDP engine for the staging disk is going to talk to OMD, Object Manager Daemon Service, and it's going to locate an existing staging disk. If this is an incremental, it'll bring that existing staging disk forward. We'll use that as an index. We'll only capture the change blocks. If we're unable to find a staging disk, then we will create a new one. This will be a full ingest, and you will see that performance warning notation in your log at the beginning of the job, generally within 2 or 3 lines of the job number. Now, in this case, we grabbed a vdisk. This is a VUID in this example, and we can actually map this VUID. Now, for other scenarios, this could be a UUID, and all these unique identifiers can be mapped in your UI, and you can actually follow the trail right to the physical disk that it lives on. So if you're unable to find a disk, you may have a path down to your storage. You may have had a disk that has stopped responding. The RAID set could be rebuilding. You could then trace down where that vdisk lives to go look at the physical health of that storage array that actually hosts the mdisk that the vdisk is carved from. Now, if that did happen, if we did have a RAID set rebuild, the pesky janitor used their mop handle and pulled the cable out of the storage, we would see a message similar to below. This is failed to fetch vdisk details for. Now here's the ID of the staging disk. So in this instance, I had an image. I had already backed it up once. I had already deduped it. I made sure the machine was well aware of it. And then I actually took the storage that hosted the vdisk out of zone to force the error. So if there's a connectivity issue to the storage, if we are queuing if no path instead of failing if no path and we can't get to the storage, or really any sort of network transmission interrupt out to the storage, or a physical hardware breakage, this is what you're going to get. You will get a failed to fetch vdisk details for. Now at this point, we can either try to repair that storage, bring that vdisk back to then be attached to the host, or we can go into the connector settings and we can just tell it manually to run a full. So back to the more successful version here. So as we go through, I do have one image that goes through the whole chain, and then I do break it out into separate jobs to force some errors just to show you what the logging on that looks like. So once we've identified and verified that we have the incremental staging disk again, then UDP says, OMD, mount it to the host. OMD, again, Object Manager Daemon, then takes that vdisk or staging disk and mounts it to the host. Now, if this is a Windows machine, once this disk is mounted, you'll be able to go into VDS, your virtual disk service, or your disk management UI, and you'll be able to see this volume mounted there. Now for Linux, FS tab. If you go into FS tab, you will see the staging disk has been mounted to your host and we're ready to write to it. And we can see here this middle log snippet that we have in blue. This is just what you could look for to verify that things are going as you expected. We found the disk. We're not seeing any errors. We're going to search for the job number. We're going to search for the VUID or the UUID, depending on where our storage is coming from. And we can also search for OMD. Generally at this portion of the job, which is going to be around 6 to 12%, if there is a failure, it's because we've either failed to connect to the host or OMD cannot get to the staging disk. So if you're having a job that's failing right in that certain percentage range, again, about 8 to 12, do some searches for OMD in these logs once you've got them on your desktop. And if it is an issue with OMD finding that old staging disk, it'll pop right up for you. Now, the OMD log itself doesn't have a ton of good information in it. It generally is just logging its responses to queries made by the UDPPM. I'll be referring to it as UDP, Universal Data Pipeline. So the UDPPM or UDP queries. So this bit of logging on the bottom is actually the response in OMD for the request UDPPM in the snippet above. So as we can see, it's not really that useful. It doesn't give us a lot of context, but the fact that we can see a response lets us know that the service is online, the socket is open, and it's listening. If we didn't see a response and we were failing to find the staging disk, then we could make a pretty well-informed guess that something is going on. Maybe the OMD service is offline or something is preventing the UDP service from being able to make that request or stopping the request from being honored. Okay, so now we've done a bunch of communicating and talking back and forth and verifying and finding staging disks and determining if we're incremental or we're full. We are finally ready to start writing some data. Now in blue here, all the samples today will be in a different font and in blue. There's a lot of text on the screen. I tried to make it stand out as best I could. So as we can see here, now we're at 9%. Now I remember I mentioned those percentages. If it fails between here and there, it's generally this. If you look at the bottom of the page, I've got, and these are ballpark figures, but I've got the job progress pretty well mapped out. So for the first 5%, we're connecting to the host. We're looking to see if we can find that old staging disk, and through that, determining if this should be a full or an incremental job. 5 to 9%, we're checking the existing mounts on the host. Now, if this is a VM and the mounts are disks that are in independent mode, those won't be snapped. So we'll either clean the mounts or we just exclude them, and then we'll start connecting the staging disk to the host. Now, at that 5 to 9, maybe up to 12%, that's when you'd be able to go into your disk management services in Windows or FS tab in Linux, and you'd be able to see that mount point appear. Now at 9 to 14, that's when we validate host connectivity. Now, when that test completes, when we say, are you there and can you connect to the host? As soon as the host rogers or says yes, that's when you see these entries pop up in your host operating system. So from 14 to between 88 and 95%, we're just writing data. Now, if you want to kind of see how things were going along, two things you want to look for is progress and status. And as you can see in my example above, if you search for progress, that 9, it is what you think it is. It's 9%. So we can actually track what's going on. So your environment, the way your things work, the percentages that I've put on the bottom may be a bit different. They are somewhat contextual. However, if you look for progress, you can then identify in your environment what your environment is doing at these certain percentage points. Like I said, these are a rough ballpark. We should be pretty close, but your knowledge of your own environment and the context in which the jobs progress through your infrastructure might be just a little different. And you can determine that by just really checking progress and status just to see what the CDS is doing with the host at a certain completion point. All right, a little bit more on writing to the staging disk. And now we were just looking at the UDPPM log or UDP log. We are now looking at the exact same operations that we just talked about, but we're looking at it from the UDS agent log. So again, a lot of you have seen these UDS agent logs. Some of this may be familiar, but this is the corresponding messaging in the UDS agent for what we just saw in UDP. So we can see the connection from host. There are a couple of places where I had to put in variables like host name or IP address. Clearly that's going to be a DNS name or something. And yes, the IP addresses are made up and edited after the fact. So as we can see here, we can look for the job number, just like we did in the UDPPM log or UDP log. And we can find where the UDP service has reached out to the UDS agent service, verify connection. Now, here's the more important part. The one log that you will be able to tail or interact with as the log is writing is the UDS agent log on the host. All of these root level logs that we've downloaded, they all get stopped and then downloaded. Obviously, they're not continuing to write while they're on your desktop. However, the UDS agent log in your host, you can tail and you can watch it real time to see exactly what's going on. The important thing to search for here is worker thread and then the job number. So we're just going to append worker underscore thread underscore, and I've got that spelled out in the top here, to the job number that we've been searching for all along. And as we can see here, we show it at 24.5%, and there's some good metrics in here too. It shows us how many gigabytes we've read out of how many total, and then how many copied. It gives you our throughput in megabits per second, and then we'll tell you the total amount of files. Now in this case, where you see the ellipses, I've chopped out some log. Really, this just counts 24, 25, and so on. This was an error-free job and completed, and we had a good snapshot. Now we're going to talk about what we might see, what we would search for, and what we might do if we did not just have a successful snapshot. Now the UDP or UDPPM log is probably going to be the most useful log to look at when you're trying to troubleshoot these sorts of things. There's a whole pick list here. Depending on what you're trying to sort out, there are different things you're going to want to look for. If you're just looking for progress, or you're just trying to do some investigations for automation planning, job number is still going to be the right way to go. If you're trying to look into a failure, that's what the rest of these are for. So we've got error code, and now that is intentionally ERR code, error, fail, terminated. Now terminated could be good or bad. Whenever we complete a job, we terminate it. So if all you want to do is find the end of the job, just look for terminated, and whether it ended in success or failure, keying in on that terminated word is going to bring you to the end of that portion of the logging. You can also take the error output right from the UI. So example here, job failed with error 5017. Now that one little one-liner that you get on your UI may not be all that helpful. However, if we search error 51 or 5017 in the logs, we would also see a notation that said unauthorized user access. So in this case, the failure with an error code of 5017 was a failure resulting from somebody trying to use a user account, an LDAP account, a domain account, to contact a host with the wrong username, the wrong password. It's somehow the credentials are bad. So your UI is going to show you job failed with error 5017. If you then went and found the portion of the logging that captures that job by searching the job number, and then search that 5017, then you will see the context that it was an unauthorized user, and that would tell you that there's a permissions-based issue going on. It's not connection-based. Maybe somebody just mistyped the credentials when they were setting up access to that host in our UI. So generally anything that has a warn log level, and we use standard Linux log levels, just info, warn, severe. We generally don't see a lot of severe. Generally things are caught by the warn level, but you can search for warn. It will generally be as verbose an output as searching for something like error. But if you're really just trying to cast a wide net so you can start then narrowing down on what you've found, just looking at the warn log level is a great place to start. Cancel is another good search term. Works similar to terminated. However, you will never see a cancellation after a job success. So if you manually cancel the job, you will of course see a cancellation. If we're trying to connect to a host, we'll try 5 times to exercise the multipath policies. If after 5 iterations of the multipath policies, we still can't connect with that host, we will move on and do something else. Now, after the 5th time, we automatically issue a cancellation, which works in the same way that you canceling a job manually from the UI works. So if it's a connection issue, and maybe it was a connection issue, maybe it wasn't. If you see the job end with cancel, look in the 10 to 15 log lines preceding that, look for those 5 retries, and that would help you identify a connectivity issue. Now, here are some examples of some of the things we just talked about and how using those keywords will really drive you right to the important parts of the logs. So here we're looking at the warn log level, and we've searched for error. We can see VM task has failed, virtual disk is either corrupted or not in a supported format. Now, in this case, we actually just couldn't talk to the storage. So in between these two, you'll see the ellipses and retries. We'll go through this 4 or 5 times, and then you can see the VM task failed. What was the VM task? What were you trying to do? That is in that second log example in the top line. And you can see add raw device mappings, add RDM request failed. So we really didn't have a corrupted or unsupported vdisk. What happened is we made a mount or a mapping request and we couldn't map it. In this case, it was because of a connectivity issue. And then the next log snippet down shows the cancellation, the automated cancellation, and the cleanup around it. So if you have a snapshot and you have not deduplicated it and you have not replicated it, we will not expire it. In the same way, if your follow-on snapshot does not succeed, even if your retention date for the previous snapshot has passed, we will hold on to it until we get another good snap. So as you can see here, not expiring, the very bottom line, not expiring image ID. It is the last backup image, and application, app name is still under protection. So we couldn't get you a new snap. We don't want to get rid of your old snap. We want to make sure that you can restore some level of that data. Now, similar event logs from the UDS agent. So again, that was UDPPM. We have corresponding events in UDS agent. UDS agent, again, the key search terms are going to be job number, error code, failed, terminated, the error output from the UI, or the warn log level. Almost one-to-one identical to UDP at this point, where we're trying to really troubleshoot a failure or some sort of issue in onboarding new applications. So as you can see, all these of the things that I've suggested, I have brought all of the search terms that would have been hits in your grep or your find statement. So here we can see that we failed to open a file, and maybe we're not real network savvy, and we don't necessarily know what query iSCSI adapters might mean. Maybe we're not network admins. If we scroll down, we have a little bit more, error code 5017. So what had happened in this example is the protection policy was set up with a user account that didn't have access to the storage that this SQL host was using. So when I tried to use those credentials to access this storage, we reported we can't get a disk. And if you look at all these error messages, this looks like it could be a network issue. The way we kind of call it out, we say that we can't find an initiator name. Now, the initiator name actually does live in that folder in the initiator name.iSCSI. The problem is the user that we used does not have permission to see into that folder. Therefore, the job cannot see into that folder. We can't find vdisks, and it looks a lot like network issues. The notifying quit event, error code, there it is, ERRCODE, 5017. That 5017 would have been the key to tell you it actually isn't a network problem. This is an access problem. This person does not have permission to utilize that iSCSI path. Okay, so now we're going to move on to deduplication on either the local or remote Actifio appliance. I have grouped these together because logically they are the same thing. You are moving data from one pool to another with a request to deduplicate in between. The one defining difference being remote dedupe involves some network sessions. But as far as taking data from one pool, placing it into another pool with the intent of deduplicating it, using matches from that pool to shrink its footprint is the same, whether it's local or remote. Again, the only difference is that the remote pool could be one rack over. It could be the other side of the data center. It could be the other side of the world. The network medium in between them really doesn't matter because, again, all we're doing is taking data from one pool, putting it into another pool with the intent of deduplicating it against the other data sets present in the destination pool. All right, so for good keywords to search in our dedup log. Now, these are going to be critical. Our dedup log is full of hashes and things that are not meant to be read by humans. So it's really vital that we utilize this keyword list to really bring us to the most important portions of the logs. So we're going to have job number. Job number is always going to be a good go-to. If you're ever not sure what to look for your job number. We're going to look for progress. This will display similar to how we saw in the UDS Agent Log or UDPPM, where we will have a log line, and then we will finish that log line with how much progress we have made through the job. We can also search for panic. Now, if we search for panic and we get a hit, a support case needs to be opened immediately. Panics can be caused by, there's that pesky janitor again. Not only did they pull your network cable out with their mop handle, but in an effort to fix it, they kicked their mop bucket over and they flooded your disk array. This would cause a dedupe engine panic if its pool hosting data went down in a hard fashion. You will see the engine panic. We do actually want to panic in this case. It is similar to what you found in a kernel panic, but our dedupe panic is actually a much more controlled panic. We will immediately stop touching your dedupe data. We will remove all information from cache. We'll get it written to the disk. We'll do a quick verification of our indices and our hashes, and then we stop. We will not read or write any more data until one of the Actifio dedupe engineers actually gets hands-on with this system, corrects whatever problem this is, to verify that you can then bring the deduplication engine back online and move forward safely with all of your data intact, able to be recovered, restored, or served whenever you'd like it. We're also going to look for disabled, error, fail, and certificate. Now, certificate is a unique search term for dedupe. Now, I did mention at the beginning that the ADHD log, which covers deduplication and remote deduplication, also handles all secure communication, and all communication between CDSs is secure. All of that logging also goes in here. So when we're establishing these trust relationships with these other appliances, be they other CDSs, storage cabinets, data stores, nearline cloud repositories, one of the more common things that will cause a connectivity issue is a failed cert exchange. And we'll be able to identify that very easily by looking for the certificate keyword here. Now, I did spend a couple extra minutes on the keywords. This is I cannot stress this enough. The dedupe log is incredibly verbose. The job that I'm using for this example here today was 3.2 gigabytes of incremental data. It spans 21,000 log lines and is noted in 4,539 of those lines. That is not reasonable to expect anybody to read through and pull out the pertinent information. So we've really got to be clever with our search here to really pinpoint what's relevant to us. So we're going to continue on. We're going to use the successful snapshot that we saw in slide 23. We're going to continue to follow this same image, which, remember, started off on a SQL host. Now we've snapped it. We've got it on a staging disk. We've removed that staging disk from the host. We've put it away. And now we're starting to get into the dedupe applications. All right, so we're going to start off with a healthy example of what a start of a dedupe job looks like. Now, I did snip out a bit of it. Like I said, it is very, very verbose. This section here could be anywhere between 50 and 100 lines, depending on how many other appliances we're talking to. If you've got 5, 10, 30, 50 certificates that have all been exchanged, you'll actually see all of the exchanges get enumerated in this. That's just us verifying that we can see all of our, what we'll call cluster mates, our other 5 or 10 or 50 CDS or Sky appliances that we want to be able to talk to. And it will all be enumerated here. Now, we're going to search for the job number, and all of the information that is basically a pre-qualification of the job sits in between these dotted hashes you see here at the beginning and at the end. A couple interesting things to note. If you look at the bottom line of the top portion of the snippet, you'll see sent 26675, et cetera, bytes of control data. So what we do, if we think we've seen this data before, is we will take a piece of data from what we think is the existing data set. And then we will then take it out, we'll match it up against that image that just came in to be deduplicated. And if we make all good matches, that's what our control data is. We want to make sure that the dedupe data that we looked at in the back end actually does correspond to the data hosted on the image that we've just been asked to deduplicate. So when you see that control byte data, that's what that is. That's verification that we've made some good matches and we're getting ready to progress down the right road. Another interesting bit, and this is just before it ends, is we have actual data rate, which is interesting. So it'll tell you how much throughput in bits we're getting on the deduplication process. And if you see logs that resemble this, that's great. You've got a great start to a dedupe job. And at this point, once you see that bottom hashed line go by when you're doing your log search, now we actually haven't deduped yet. Everything we've done up to this point is pre-checks, validation, and then we start the actual deduplication. And again, we're going to continue to look for the job number. Now we have a new job number because it's a dedupe job, not a snapshot job. And this is normal messaging. You can see the ADHD, 2-cop, merge, sequence, num, diff, offset. Now that offset is actually sector offset. That has to do with actually sector drift and data drift. Honestly, nothing you need to worry about, but I do want to point it out and just kind of explain what some of this stuff is so you have an idea of what you're looking at when you get in there. The important part is with the job number, we can also find progress. So if we have a dedupe job, a remote dedupe job that we feel like, maybe is running a little bit long, we can actually look in and see the real-time progress. As we know, sometimes the UI doesn't update as frequently as we'd like, especially when we're really waiting on that data and we're kind of camping out on it. The whole watch kettle never boils kind of scenario. So we can actually just look at progress. We can see what's going on. And also if we do run into some sort of an issue, we can use progress to identify at what portion of the job we encounter the issue. A couple more details on that in a moment. Now is when we will start to get into some error tracing. Now, because these logs are so verbose, in the scope of this webinar, I can't cover every possible scenario that we might want to track down. What I can do is cover how to do this research and some example use cases that you can then leverage to do analysis of your own environment. So error is always going to be, whenever you're looking at a log, you can always search for error. If you want an actual error code, if you're trying to find context around an error code that you saw reflected in the UI, like that 5017 we saw earlier, search for error code, ERRCODE. That's in one of the earlier slides. If you're not really sure what went wrong, and again, we're going to cast a wide net, we'll just start with error. So as we can see here in bold, we've got some hits. So for this example, what I actually did was I disconnected the storage for the dedupe. So while this dedupe job was in flight, I disconnected the disk from the actual Actifio appliance. And as we can see here, error 32 from send, that's from the source machine, broken pipe. So that means that the interface on the machine that was sending the data out went down, but through other monitoring, we actually can still see the remote device. The remote device is online. So we can identify that it came from the send side, not receive side, and that will help you narrow it down a little bit if you are trying to chase a network issue in your own environment. Now, the second one down, it sounds super scary, but it really isn't. Now, the super scary part is that last bit. Unrecoverable error 5 from RDUP start. Let me tell you what this actually means. You were doing a remote dedupe job. In the middle of your remote dedupe job, the interface went down for long enough that the network session got terminated. Now, if you see this error message, I would ask that you don't go any further. Please call our support team. We actually do have some mechanisms within our product to capture these, and we have a resume functionality. However, there's some manual bits that we need to put in so that we can identify to the job at what point it failed, so we can go back and retrace a little bit, do some validation of the previous 2 or 3 network sessions, make sure all that matches, and then continue on from there. So if we failed at 70%, when we resume, we probably come back between 60 and 65. We verify that 5 to 10% to make sure that we're in sync and everything's right, and then we continue through to the end to complete the job. If this happens to you and you just want a little extra assurance that things are going the way you expect, when you pull these logs out, search for progress. And this unfortunately does take a little bit of digging. As you'll notice in this log snippet at the very bottom here, there's no job number because these events are not being logged at the job level. These are actually events at the dedupe engine level. So if we're going to use something like Emacs or PowerShell, we could actually look for lines that do not have a job number. We could use a little regex and we could get right to this. Now here we've got error 241. Now there are a bunch of reasons that you could get an error 241. Now normally this is going to be a communication issue. This could be a disk availability issue. Remember that queue if no path, fail if no path? So queue if no path, we know the path is there, we know the storage is behind it, and everything is online. Nobody's reporting an error because the requested behavior, which is to queue, has been observed. However, we still can't make our snap, so we're still going to complain. Error 241, data movement subjob failed. So when you hit this 4 bullet points for things that you can do a quick check on to rule out some very common causes. Sometimes the target appliance IP, we all make mistakes. Maybe you put a 1 in instead of a 2. Just make sure we're sending it to the right place. This is especially important when you've got multiple appliances deployed and you're using consecutive cluster IPs, .01, .02, .03, .04. Very easy to just press one key the wrong way, and now we're trying to send it to an appliance that we maybe haven't had a certificate exchange with. And because we don't have a certificate exchange, we can't open a strong network session, so we result in an error 241. We need to make sure that the remote appliance is online and available. That means all the paths are up, all the services are up, dedupe, UDP, all the things that we talked about in that 9-square slide, all of those things have to be online to make sure that we can then take the data at the remote site and protect it. If we can't verify that that remote site is a good target for the data and we can ensure your data protection, we will stop what we're doing and we will report that we cannot get the data off board. Now, if this causes snapshots to stay in the snap pool beyond retention, they will be held until the remote transmission is complete. We need to make sure we have copies on both sides before we allow that expiry to take place. Now, the last 2 bits have to do with pools. The pools have to be online. That is to say the storage must be connected and zoned in. And the remote dedupe pool has to have space. Obviously, if your pool is 100% full and we need to send a terabyte, we have no place to put it. So you will get the 241. It's not to say that that dedupe pool is not there. It's not to say that the services are offline or the link is down. It's that it's full, so it is not available as a target for this replication data. 2 other more common ones, and this is the 1055, and there's 2 contexts for it. That's remote replication to the remote cluster is either off or down. So there are certain things that could happen. Let's say your dedupe storage goes offline. Our dedupe engine sees it, throws a bunch of alerts. What it may do to prevent itself from writing into the dedupe pool and causing possible corruption is it will shut itself off. So if you are getting an alert on your desktop or in your health widget on the dashboard in the bottom right where it says snap pool dedupe pool, if that dedupe pool is red, we can then pull that ADHD log down and we can search for disabled relevant to the time. And again, all of these log messages do have detailed timestamps on them. I just took them out for the sake of saving room on the slide. So if you have an idea, I saw that the dedupe pool was online an hour ago, you can narrow down your search and then search for disabled, and you will see dedupe disabled equals 1. Now dedupe disabled obviously needs to be equal to 0 for it to be enabled. If you find this, please go ahead and reach out to our support team. They can look at and see why it's disabled. Perhaps somebody's doing maintenance and they didn't communicate that with you and dedupe was shut off for a reason. Perhaps there's a storage migration going on, an upgrade impending, or there are various other maintenance ops where you would really want to make the system kind of stoic and still. So if you do see this, give us a call. We can take a look. We can give you a good idea, not only of who shut it off, but when they shut it off and why, even if that person is your organization. Now we're going to get into these certificates I talked about before. This tends to trip a lot of people up. We get kind of wrapped up in the iSCSI, the SAN, and the fiber channel, and the remote replication, and the certificate can kind of fall by the wayside. So if you've checked, your zones are right, your VLANs are set up, your ports are tagged, everything is rock solid, but for some reason it just won't connect, search for the word certificate. And I always recommend a case insensitive search. Sometimes you'll see error with a capital E, sometimes you'll see it with a lowercase. You don't want to miss those. So like a grep-I, or just put a tick in the ignore case box under your search box for a Windows search. Here's that error 241 again. So this one is actually, well, this is a feature, and I'm going to explain it to you because I do get a lot of questions about it. Now this error specifically is full ingest to dedupe, not supported during dedupe GC. Now you've got to be familiar with the garbage collection. While we're doing the garbage collection, we are pouring through all those indices and hashes in your dedupe pool. They are super transactionally heavy and they are very compute intensive. And when you're managing all these different pools and all these different disk arrays, the safest way to go through these indices is to just stop changing them. So we kind of freeze things for a moment, and then we'll start validating these hashes, validating these indices. And then once we've done a chunk of it, and it really depends on how much we have to do. I wish I could tell you, once we do it for 15 minutes, we'll release the file system for an hour. But really what it is how many, not necessarily how much data is in there, but how many total hashes have to be analyzed. So if it's 1,000, we may lock out your full ingests for 2 or 3 hours. If it's 100,000, we may lock out full ingest for up to a week. If that does become a problem, then one of the solutions you could use is to actually deploy a second appliance. A Sky instance is a great backup for this sort of thing. Once your dedupe pool starts to get really, really heavily full, it does hurt performance, just like it would for any file system that you're starting to push over that 90% mark. So if you really need to feed a lot into your dedupe pool and you need to make sure that no matter what, you can always take a new ingest of a new app at any time of day on an emergency basis, setting up a small Sky appliance to then capture that data and you could send it back over to your main CDS via replication policy later is a great little stopgap for getting around that file system clamping if you do have either an underperforming or overconsumed dedupe pool. Okay, so I know we've covered a lot of ground today. This has been recorded. And in addition to the recording, I'm also going to give you this exact slide deck. There are no speaker's notes. Everything that I prepared for today, you did see on the slides. And I really think the best way for me to get this message to you was really to kind of cover it like a lecture and kind of go everything at a high level. But I really want to send you home with all of this content so that you will have it to go along on your own while you're watching the recording later. The recording will be available on YouTube. We also have a bunch of other great enablement videos on there. Earlier, I mentioned the network self-service panel in the resource center. We've got a great video on that. We've got a great video on how to install Sky. We've got a bit of a high level on Report Manager, again, to really get into not what's in the doc on Report Manager, but to really look at practical use cases that affect you on a day-to-day basis. You may want to sign up for Paul Martell's Report Manager webinar in the coming weeks. Thank you for joining us for another YouTube Tech Tip video. If you like the content you're seeing on this channel, please remember to like the video, subscribe to the channel, and turn on notifications so you will be alerted to any future content.